Good morning, everybody. How are you all? This is Dr. Nandi. Today we are going to talk about solving ordinary differential equation using separation of variables. So I will share my screen with you. In a chemical reaction, a chemical compound changes into another compound at a rate proportional to the unchanged amount according to the model dy by dt is equal to ky. Solve the differential equation. If the initial amount of the compound is 20 grams and the amount remaining after 1 hour is 16 grams, when will 75% of the compound have changed? So let's create some space. Okay, so solution. So we have dy by dt is equal to ky. We will separate the variables, so we will divide by ky on both sides and multiply by dt. We will actually divide just by dy by y. So ky by y, and we will multiply by dt on both sides, which leads us to dy divided by y is equal to k dt. We will now integrate dy by y is equal to integration k dt. Now k is a constant, so we have ln y is equal to kt plus c, where c is an integration constant, where c is equal to constant. Okay, so we can call this integration constant actually c1. Okay, now we have been given some information. If the amount of the compound is 20 grams and the amount remaining after 1 hour is 16 grams. Now at t is equal to 0. So this is the answer for part 1A. We can further change it into y equal to, we take the, we raise everything to the power of the natural number e on both sides. So we get e kt plus c1, which can be further written as e means natural number exponent kt multiplied by e, again the natural number raised to exponent is c1, which is a constant, which can be written as, since e to the power of c1 is a constant, we can write this entire thing, e to the power of c1 being a constant, as c, which is another constant, and e kt. Okay, now at t is equal to 0, it has been given c is equal to 20. Okay, so we are into part B. Okay, so since y equal to c times e kt from part A, so now we will okay, we'll move this a little bit up so that we can create some space for us. Okay, so 20 is equal to c e k times 0, which is equal to c times e to the power of 0. Anything raised to the power of 0 is 1. So c. Thus, c is equal to 20. So we can write the equation for y is equal to 20 e k t. Okay. Now, another information we have been given. Again, I'll create some space for us. Okay. So, okay. So after 1 hour, if t is 1 hour, so at t is equal to 1. Where is this? After 1 hour, c is equal to 15. C is equal to 15. So if we plug that information, we get y, which is equal to 15, is equal to 20 e to the power of k times 1. Okay. So we will divide by 20 on both sides to get 15 divided by 20 is equal to e to the power of k. For t, I'm going to plug in 1. So 15 over 20, 5 is the common factor. 5 goes into 15 3 times, and 5 goes into 24 times, is e to the power of k. Okay, so there's a mistake here, little bit mistake, so I'll fix that. This is actually t is equal to 1, t is equal to 1, c is equal to 16. So this will be 16 over 20. Okay, so you can say this. So at this is 16 is equal to 20. So now divide by 20 on both sides. 16 over 20 is equal to ek times 1, or e to the power of k is 16 over 20. Again, 4 is the common factor. It is 4, because 4 times 4 is 16 and 4 times 5 is 20. From which, if we take natural logarithm of both sides, we get ln of 4 over 5 is equal to k. Okay, so now we can write the expression for y. Okay, so we can write y is equal to 20 e to the power of ln 4 over 5, substituting the value of k times t. Okay, and this is the expression for y. Now we have been asked, when will the concentration, or when will, let me bring this down a little bit so that we can read it. So it says, if the initial amount is of the compound is 20 grams, from which we found the value of the constant C, and then from the second information, amount remaining after 1 hour is 16 grams, we obtain the value of K. Okay, so we have the expression for Y now, and we have been asked, when will 75% of the compound been changed? Okay, so initially it was 20. Okay, so initially it is 20. So 75% of 20 is equal to 0.75 times 20 is equal to 15. So they're asking, when will the 75% of the compound be changed? So amount remaining amount remaining will be 20 initial at t is equal to 0 and 15.75% have changed. So the amount remaining is 5. Okay. So we know this is the value of y. Question is, what is the value of t when y is equal to 5? Okay. So let's plug this information in the equation for y. 5 is equal to 20 e to the power of ln 4 over 5 times t. Okay. So much like before, we'll divide both sides by 20. We get 5 over 20 is equal to e ln 4 over 5 times t. So again, 5 is the common factor. 5 goes into 5 itself 1 and 5 goes into 24 times is equal to e ln 4 over 5 t. Okay. Now we take the natural logarithm of both sides. Okay. We get ln of 1/4 is equal to ln 4/5 multiplied by t. Now we divide both sides by ln 4/5 to get ln of 1/4 divided by ln 4/5 is equal to t. So now we have to use our calculator. Ln of 1/4. So ln 1/4 being 0.25 is equal to minus 1.386 divided by ln 4/5 is equal to 0.8. So ln of 0.8. So ln of 0.8, and that's equal to minus 0.223 is equal to t, or t is equal to 1.386 divided by 0. Actually this 0.223. So 0.223, okay, which is equal to 1.386 divided by 0.223. And the answer is t is equal to 6.2 on. Okay, so this is your final answer. Okay, that is when the compound has lost 75% or 75% of the compound has been converted to another compound and only 25% is left. Yes, let me check and make sure the answer is correct. Yep. So T is 6.2 hours is the final answer for part B. So I'll stop here today. If you have any question, comment, please write me a note. I'll get back to you as soon as possible. And if you like this video, please give me a hearty thumbs up. I really appreciate that. And if you like this video, please let your friends know about it so that they can subscribe to my channel by hitting the red subscribe button at the bottom right corner. And you also please subscribe to my channel by hitting the red subscribe button. I'll come back next time with another interesting problem, interesting solution. Take care. Have a nice day. Thanks for watching. See you next time. Thanks.